In section 3.6, we're going to take special types of lines. In particular, parallel lines and perpendicular lines. Now, if you look at the gray box in the middle, it says two distinct lines in a coordinate plane either intersect or are parallel. Parallel lines are lines that never intersect. And here's what you're going to do today. You are going to use the slope of both parallel and perpendicular lines to write an equation, or to determine what the equations look like. So look at the key concept on the bottom of page 212. We have slopes of parallel lines. In words, here's what it means. Non-vertical lines, so we're not talking about vertical lines. Non-vertical lines are parallel if they have the same slope but different y-intercepts. Now the reason why they put different y-intercepts is because if you had the same slope and the same intercept, you'd have the exact same equation. So you can't have parallel lines if you have the same equation. Vertical lines are parallel if they have different x-intercepts. You guys all know vertical lines are straight up and down. They have an undefined slope. So vertical lines are also parallel. In the graph, as you can see, there is a red line and it looks like a brown or a purple line. It says y equals 1/2 x plus 1 and y equals 1/2 x minus 2. You will notice that both lines have a slope of 1/2. Therefore, because the slopes are the same, we have parallel lines. So now we are going to use the fact that slope of parallel lines are the same to write an equation of a line. So I want you to look at problem 1 and the got it at the top of page 213. In the got it problem, it says that we have a line that passes through the point -3, -1, and is parallel to another line, which is y equals 2x plus 3. So we have two lines. Line 1 passes through the point -3, -1, and the second line already has an equation. We know that these lines are parallel, and we need to find an equation that represents the line in slope-intercept form. So you have to write an equation for this. And in order to write an equation in slope-intercept form, we need two pieces of information. The slope, which is m, and the b, which is the y-intercept. So now we know that both of these slopes are the same since these are parallel. So what is the slope of line 2? The slope is 2. So that means the slope of this line has to also be 2. We now have to use slope-intercept form to find b. So we use y equals mx plus b. We plug in our x, we plug in our y, and we plug in our m. That would give us the equation -1 equals 2 times -3 plus b, which would be -1 equals -6 plus b. We add 6 to both sides, and that gives us 5 equals b. So 5 equals b. So I write my equation, y equals 2x plus 5. So my equation would be y equals 2x plus 5. You have to find the m and the b and use that to plug it into slope-intercept form. Example number 1 is the same type of problem. I want to write an equation in slope-intercept form of the line that passes through the point. So I need to find an m and a b. Since my m is the same as this line, my m is going to be a slope of -3/2. My b is still what I need, so I take my x and my y, my point, and I plug them in. That would give me -1 equals -3/2 times 2 plus b. B equals -3 plus b. B then would be equal to 2. So I take those, plug them into my equation, and my equation in slope-intercept form would be y equals -3/2 x plus 2. And number 2, if you want to write it down, number 2 you can do on your own if you like. The answer is going to be y equals 2/3 x or 2/3 x plus 0. At the bottom of the page, on page 213, we have another key concept. We talk about perpendicular lines. Now let's review what perpendicular lines are. Perpendicular lines are lines that intersect to form 4 right angles. So your key concept in this whole thing, I want you to look over it and make sure you understand it. But basically what it says is, if you have 2 lines that are perpendicular, their slopes are going to have a product of -1. That means one slope and the other slope multiplied together would give you -1. Now the only way that does not work is if you have a vertical and horizontal line, and that's represented here on the key concept. A vertical line has a slope of undefined, and a horizontal line is 0. Well, 0 times an undefined slope does not give you -1. So you just have to know that if you have a vertical and horizontal line, their slopes are going to be perpendicular. So let's start with an example using this. Turn your page in your book to page 214 and look at the gray region at the top. Opposite reciprocals. Now I'm going to show you some examples of how this would work. -3/4 and 4/3. Those are opposite reciprocals. You take the reciprocal and you change the sign. So for example, -1 and +1 would be opposite reciprocals. 2/5 and -5/2 are opposite reciprocals. Now if you multiply these all together, these are all going to give you -1. So these represent slopes of perpendicular lines because their product is -1. So now let's look at problem 2. Problem 2, you are classifying the lines as perpendicular, parallel, or neither. So the first thing you have to do is identify the slope. So in A, it says y equals 3/4 x plus 7. Piece of cake. M equals 3/4. In the second equation, 4x minus 3y equals 9, you first have to solve this equation for y. So the first step is going to be subtracting 4x on both sides. That would give me -3y equals -4x plus 9. I now have to divide everything by -3. That is going to give me y equals +4/3 x minus 3. Now once again, if you wanted to show this step by dividing everything by -3, you can. Here my slope is 4/3. So you ask yourself, are the slopes the same? They are not. Do they multiply to give you -1? Are they opposite reciprocals? They are not. Therefore, these are neither parallel or perpendicular. In problem B, we have 6y equals -x plus 6 and y equals -1/6 x plus 6. Step 1, solve for y. Divide everything by 6. That gives me y equals -1/6 x plus 1. And here is y equals -1/6 x plus 6. They both have different y-intercepts, and their slopes are the same. Therefore, these lines are parallel. Now let's look at example 3. Y equals -7, x equals 2. Right off the bat, you should be like, oh, I don't even have to do anything. This, if you remember, is a horizontal line, and x equals 2 is a vertical line. If one is horizontal and one is vertical, your lines are going to be perpendicular because they form right angles. Problem 3. We're now going to be writing an equation of a perpendicular line. So we know that our line passes through the point 1, 8. And it is perpendicular to the graph of y equals 2x plus 1. So we need to write an equation of the line in slope-intercept form. Once again, y equals mx plus b. I first need to find my slope. Well, my slope of this line is 2. I need to find the reciprocal and the opposite. So I need to flip it and then change the sign. So if I flip 2, 2 over 1 is going to become 1/2. And I have to do the opposite. So my slope is going to be -1/2. So my m is -1/2. My x is 1. My y is 8. Let's plug it in and solve for b. 8 equals -1/2 times 1 plus b. 8 equals -1/2 plus b. I add a half. That gives me 8 1/2 or 17 halves equals b. I plug it into my equation. Y equals negative 1/2 x plus 8.5. And that is my answer. Example number 5. We want to write an equation in slope-intercept form of the line that passes through the point 5, 0 and is perpendicular to the graph of the given equation. The first thing we have to do is solve the second equation for y. So if I distribute, that's going to give me 2x minus 6, and I subtract the 1, so that will give me y equals 2x minus 7. So my slope is 2. I have to do the opposite reciprocal, therefore my slope is going to be, of this line, negative 1/2. I use slope-intercept form to plug everything in. My y is 0, my m is negative 1/2, my x is 5, plus b. 0 equals negative 5/2 plus b. I add 5/2. That gives me b is 5/2, or you can say 2.5. So you set it up. Y equals 2x. I'm sorry, not 2x. Got to be careful here. It'd be y equals negative 1/2 x plus 5/2. So I take my m, plug it in here. Take my b, plug it in here. The last example we're going to do is from section 4, problem 4, solving a real-world problem. Turn your book to number 7 on the top of page 216. The problem says, a path for a new city park will connect the park entrance to Main Street. The path should be perpendicular to Main Street. What is an equation that represents the path? So I have drawn a rough sketch of what you see in your book. So remember, I want to write an equation that represents the path. And the path has to be perpendicular to Main Street. So our path has to go through the 4. So what are the only two things I need to write an equation? A slope and a y-intercept. We know the y-intercept. Here I'm going to quickly draw a rough sketch of a line. So I want to find the equation of that blue line. There are two ways to do it. Way number 1. Let's start with b. What's your b? Where does it cross the y-axis? It crosses the y-axis at 4. You can now pick 2 points on the red line. So if you look, where does the red line cross at a point that I can figure out? Well, if you look at your thing, it says 2, 1. Looks like where it crosses. And 3, 3. Now once again, what I have drawn is a rough sketch. So I know that this point here is 2, 1, and this point here is 3, 3. Let's find the slope of that line. Subtract my y's, subtract my x's. That gives me a slope of 2 over 1, which is just a slope of 2. So if we're talking about perpendicular lines, that means I have to do the opposite reciprocal. That would give me a slope of the blue line of negative 1/2. So therefore my equation will be y equals negative 1/2 x plus 4. So what do? We found the slope of the red line, did the opposite reciprocal to find the perpendicular slope of the blue line. We already knew our y-intercept was 4, so I plugged them in and got my correct equation. So to review, parallel lines have the same slope. Perpendicular lines have a slope that has a product of negative 1.